So sketch f of x is equal to 1 over x minus 5 and x plus 5. No, well, let's do the one which we do the one on top here, which will require us to equate the, I think that's why there was much issues there. So we'll do something like x plus 3. Yeah, something like this. Well, I'll sketch this rational function. Solution. We start by finding the vertical asymptote by equating x minus 5, x plus 5 to 0, so that we get x is equal to 5 and x is equal to negative 5. So these are the vertical asymptotes. Then horizontal asymptote. Look, f of x is the same thing as x plus 3 over x squared minus 5x plus 5x minus 25, which is x plus 3 over x squared minus 25. So the degree of the denominator is higher than that of the numerator. What does it mean? Horizontal asymptote is a line y is equal to 0. This one. Or if you went for the limit method as x goes to infinity, then you would say x plus 3 over x squared minus 25 is equal to the limit as x goes to infinity. Factor out x squared from down, then you have 25 over x squared, and on top x squared, then you have 1 over x plus 3 over x squared. Then these will cancel, and then we'll get, since we said that the limit as x goes to infinity of 1 over x is 0, so it is for 3 over x squared, for 25 over x squared. So we'll have 0 over 1, this one here, which is equal to 0, which is what we have obtained here. Then you should be able to get me, please. I'm struggling like this. Okay, yeah. Hope you're getting me now. So now we get the y-intercept. Which is f of 0, which is 3 over negative 25. Because you just put 0 here, you put 0 here, you remain with 3 over negative 25. Okay. X-intercept.
I can't get you, sir.
Am I audible enough now? Hello?
Yes, sir, you are audible.
Thank you. So the x-intercept, we equate the numerator x plus 3 to 0. So we get x is equal to negative 3. Okay. Then this is a case where we're looking for the x-intercept, and then now we're supposed to go and equate the whole function to the horizontal asymptote because the numerator has an x variable. It turns out that when you do so, what we'll get, if we equate the whole function to the horizontal asymptote, which is 0, what we'll get is x plus 3 over x squared minus 25 is equal to 0, which is simply x plus 3 is equal to 0. So x is negative 3. That very thing. So when we sketch, we have the x-axis, y is equal to 0 as the horizontal asymptote. We also have, which one is that? X is equal to negative 5 here, and x is equal to 5 as a vertical asymptote. So this is 5. This is negative 5. And so it puts here. So now we sketch. Remember, the y-intercept is negative 3 over 25. 3 over 20, somewhere here, somewhere close here. Negative 3 over 25. Then the x-intercept is x is equal to negative 3. Somewhere here. Negative 3. Evans.
Sir, numbers like the same 3 over negative 25, how can you estimate what they're supposed to be like? Is there nothing, time finishes, do you just guess that it will be here?
Yeah, like since this is not drawn to scale, you just know that this number is less than 1.
Oh, okay.
Yeah, so you know it's less than, so meaning it's bigger than negative 1. So you, negative tells us that it's below 0. So now, okay, don't worry more, no. So we sketch. In fact, for us to do a good sketch, I think, let me sketch first and I'll put the points. So to sketch, we'll have something like this one. We'll have something like this. Crossing. So we'll have something like this. Because it's crossing, so it will cross here at negative 3, here at negative 3 over 25. So though we have an asymptote, but that's crossed the asymptote in the middle here because we have an intercept that lies there. This is for the reason that the numerator has a variable x. Then now we pick a number bigger than 5.
Oh, okay.
So we pick a number bigger than 5. Hello?
Sir. Like from here, do you need to make a cut table?
No, not necessarily. What table A? So let's pick 10. 10, I said is easy for calculation. So f of 10 is 10 plus 3, we get 13 on top. 10 minus 5, we get 5 and 15. The number is positive. That's our interest. So the graph is above 0. Then negative 10, we'll have negative 10 minus 3, negative 7 over negative 15 multiplied by minus 5. So this is negative 7 over positive 15, 15, 30, 15, 15, 30, 60, 75. 75, which is negative. So the graph is going to be down here. That's how we do the sketching. So I've used negative 5, positive 5 to pick the numbers 10 and negative 10. You pick a number bigger than 10, a number smaller than bigger than 5 and smaller than negative 5. Then what you get, you compare with the horizontal asymptote. Now, what I said here is 0. So I'm comparing with 0. And then there was a question on how we got the limit. So how do you get the limit? We said that since x is going to infinite, we factor out x squared. So we factor out x squared, and then we have 1 minus 25 over x squared. Then remember we said that the limit as x goes to infinite of 1 over x is always 0. So once we see x in the denominator and it's going to infinite, these are giving us 0, 0, 0. So we have 0 over this one here. So you eventually get 0. Like that. Super. Yeah, that's okay. That's okay. Okay, then what else? What else? Something next. B. We talk about. I'm trying to mute.
No, thank you.
Okay, so we sketch. Maybe we do 1 minus x and 1 plus x. When x is less than or equal to negative 1, x squared, when negative 1 is less than x, which is less than 1, and 1 minus x, when x is greater or equal to 1. The question is sketch. I have piecewise functions like this one. Yeah. I've seen it in so many test papers. This question. So want to sketch? So to sketch here, you go direct and put the sketch. So we have two numbers, negative 1 and positive 1. Well, if we want, we can start from the middle one. F of x is equal to x squared. For x, negative 1 less than x less than 1. So you pick negative 1, substitute it in the function. You get negative 1 squared, which is equal to 1. So we have negative 1, 1. Remember, it's not included, so we'll open there. And then the other one at 1, so f of 1 is 1 squared, which is 1. So again, we open there, also gotten 1, 1. Then 0 lies in this interval, f of 0, 0 squared, which is 0. So it will touch here. And then we put the sketch. Like this. Then you go to the right, f of x is equal to 1 minus x whenever x is bigger or equal to 1. So you start at 1. So what is f of 1? That's 1 minus 1, which is 0. So you're at 1, 0, you close. Pick a number like 2. What is f of 2? You get 1 minus 2, which is -1. -1 is down here. So it's somewhere here. So it's a straight line like this. Then the other side, we now go up this one. F of x is equal to 1 plus x when x is less or equal to -1. So what is f of -1? That is 1 plus -1, which is 0. So closed here. Then pick a number, say -2. F of -2 is 1 plus -2, which is -1. So we have -1, comma. Function coming down here. So I have a complete sketch. Is it important to label? It's not important. Once I label that this is B, then it's enough. To show the working, yes. So you show this, you show this, you show this. Mr. Ndambo. The German man. You are welcome. Questions? Evans?
So like on these graphs, if you extend them further, like that one touching at -1, I'm sure it can even cross the y-intercept. Why doesn't it cross?
You don't have to be sure. It's very dangerous. Oh, so suppose you say, what is f of 0? And you're using the first function. You get 1 plus 0 to be 1. Then you want it to cross. It should go and cross there. Is that the case?
Yes.
No. It doesn't do that. Because when you say f of 0, you have no space in here to take 0. When you say f of 0, Then you go back to the intervals here and check where you find 0. 0 is not less than -1. First thing, 0 is not bigger than 1. So it can't work in the first function. It can't work in the top function. The only place you find 0 is here in between -1 and +1. So you substitute 0 in this function. And that's why you find the 0 one is only used once here. Does it make sense?
Thank you, sir. It's clear.
Okay. Okay. Is this function onto? Again, they say
Sir, sir.
hello.
Yeah, so these numbers that you are picking, it shows that you're not just picking them from nowhere. You are following the range within this, the function that we have been given on top here.
Yeah, so
I don't know.
yeah, your question is in English. When you say the range, that's English. Mathematical, we are following the domain.
Or interval.
Okay. The domain of each piece. Because we have 3 pieces, the first piece is f of x is equal to 1 plus x. Now you want to sketch, you ask yourself, where is it 1 plus x? It is 1 plus x only if I had a number line. You go at -1. Starting from here, going to the left, the function is 1 plus x. Starting from here, opening, all the way open up to 1, the function is x squared. Closed up to positive infinity, the function is 1 minus x. So when I want to use 1 plus x, I come and pick numbers in this interval. When I want to use x squared, I come and pick numbers in this interval. When I want to use 1 minus x, I come and pick numbers in this interval. That is how the function covers the whole real line. Does it make sense?
Yes.
So I said, how are you finding all these points? Oh, how many points? 1, 2, 3, 4, 5, 6, 7. We start from that's the question. That's not the question. Let's see the person speaking. Your network is not that strong, so you can type a message.
X is less than
Okay, I could. I didn't get this person. Let me see. What's the use of the horizontal line test? And is there a vertical line test? If you have this, and I have this, vertical, a horizontal line test, you are checking if the function is one-to-one. If it touches twice, here and here, then it's not one-to-one. Because the horizontal line test has failed us, it has touched twice. If it is like this, you do this, it's touching once, then you know it's one-to-one. Is there a vertical? Yeah, there is a vertical line test. But what is a vertical line test? Oh yeah, vertical line test. You want to check if it's a function. Is it a function? Use a vertical line test. If it's touching once, it's a function. It's not a function because it's touching twice at a single value of x. So it's like I have x is 2, then I'll have y -4 and +4. So there'll be something like this. So it's not a function. I think just bad that my voice is not cool, as you can hear.
Sir,
Yes.
so my network is very bad where I am. It's very, very bad. So I've missed how you've sketched all those. I'm asking if you can just go through them as fast as possible. Help me.
These same structures here or the ones on the other page?
This same one, sir.
All right. So here, the question we are trying to answer here was, how do you use the horizontal test? So you're saying if there is such a sketch, the horizontal test is just to check if a function is one-to-one. That's it. If it touches twice, then it's not one-to-one. The vertical test, you want to check if the relation given is a function. So if we have this such a curve, the vertical test, the vertical line test, if the line touches a graph once, then you say it's a function. Then we have another one here where the line touches twice. An example is here. If this is 2, then you have +4 and -4. Then it's not a function. No, the diagram we are just drawing. There's that. It's very knowledgeable of how they're coming up. Yeah. But it's bad, eh? Right. Let's come up close. Okay. We end here. It was very heavy. Struggling. So what will happen is tomorrow we won't have a class, but we'll have a class on for math. Forget about as math is concerned, eh? There are no classes to my team. So what will happen is tomorrow I won't have a class, but on Thursday, if we agree now, on Thursday, we'll have a class at 8. No, Thursday, yeah, at 8. 18 to 20. And on Friday, no, Friday, Saturday for some people. So on Saturday, again, 18 to 20. Yeah. So we have these 4 hours on Thursday and Saturday. So this must be okay.
Sir,
Yes.
hello. So when are you having the test?
I wanted to give a test, but the trigonometry part, others haven't learned. So I think it will be there, but on Sunday. We agree on Saturday what will happen, but I think it will be there on Sunday. I'll know what to put in there. Well, we have revised so many things, but I think by Sunday,
Okay.
Saturday will be done revising. So I can give a test on Sunday. So I will just see if it was beneficial to do the revision, the catch-ups.
Starting doing trick.
After Sunday. How you opening, right?
Sorry.
We'll start after like a simple assessment on Sunday. Then we'll go into trig.
Sir,
All right. All right.
Then
Once we open, are we going to be having physical classes or we'll be doing it online?
once we open,
Yes.
it's physical at main campus, online at region.
All right. Okay.
Yeah.
Sir, before you cut the video, can you don't forget to send the videos for the previous lessons,
I won't
the ones we
forget.
had before the plan. Yeah.
Don't worry, I won't forget. After trig final. Yeah, the school guide. Don't worry.
There's boy.
Concern. Test quiz. Test quiz.